Hi friends, welcome back. Today we are going to solve another popular and important Leetcode coding interview question 2086 minimum number of food buckets to feed the hamsters. As you can see here from like dislike ratio, this is another likable medium complexity array related coding interview question. So we are going to go through this problem, we are going to understand this problem with few examples, and we are also going to implement our Java solution code. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, Java programming and coding. So let's start. You are given zero index string hamsters where hamsters I is either h indicating that there is a hamster at index I or dot indicating that index I is empty. You will add some number of food buckets at the empty indices in order to feed the hamsters. A hamster can be fed if there is at least one food bucket to its left or to its right. More formally, a hamster at index I can be fed if you place a food bucket at index I minus 1 and or at index I plus 1. So he should have a food bucket on its left or right or both places. Then he can be fed, right? Return the minimum number of food buckets you should place at empty indices to feed all the hamsters, or minus 1 if it is impossible to feed all the hamsters, right? So this is what the problem says. So we'll go through these examples. Uh, so constraint says that the hamster's dot length is between 1 to 10 raised to 5. So the string that is given to us, that hamster string can have maximum 1 lakh characters, right? 10 raised to 5 is 1 lakh. And the characters that can be present in that string are h or dot, right? H is for hamsters, dot is for the empty space, right? Okay, so let's take a look at these examples so it will be more clear for you. So this is the first example where you can see that there are hamsters at index 0 and 3, right? And there are two empty spots. So you have to put buckets in both these spots, right? 1 and 2, so that the hamsters can be fed, right? One hamster can be fed if it has a left side bucket or right side bucket, right? So now you cannot put a left side bucket because this is index 0, so you have to put a right side bucket. So the bucket will go at index 1. Okay, for hamster 0 he will use index 1 bucket to feed, and hamster 3 will use index 2 bucket to feed him, right? So total 2 buckets will be required minimum, right? So as you can see, 2 buckets is the answer here. Okay, this is another example where you have 0 is empty, 2 is empty, 4 is empty, right? And hamsters at location 1 and 3. So you can place a bucket at index 2, right? So the index 1 hamster can eat that from that bucket because it's on its right side, and index 3 hamster can also eat from that bucket because it is on its left side, right? So only one bucket can is enough actually here to feed both these hamsters, right? So minimum number of bucket required is 1 here. You got it, right? What they are saying. So this is what the problem says. So we want to basically, our goal is to minimize the number of buckets. So here another example is here. So there are 3 hamsters. So as you can see here, 0 is empty, 4 is empty, 1 to 3 has 3 hamsters, right? So as you can see, the hamster 2 will not get any food because it is surrounded by hamsters, right? Hamster at index 2 is surrounded by hamster at index 1 and hamster at index 3. So he cannot get food. So you cannot feed all the hamsters. So you will return -1, correct? So this is what the problem says. So now you understood the problem, I hope, what they are saying with these examples, right? So our goal is to find minimum number of food buckets that we can place at any empty indices so that all the hamsters can be fed, right? So here is another example I created. So this is an example where h is a hamster, dot is an empty space, right? So this is an empty space, right? This is an empty space, this is an empty space here. This is an empty space, dot means empty space, right? dot means empty space, empty space, empty space, right? So 1 2 3 4 5, so there are total 5 hamsters, right? So minimum number of buckets, where should we keep the bucket, right? Where should we put the bucket so that it can be minimum number of buckets? So I can put one bucket here, right? So I can put one bucket here and it can feed these both hamsters, right? Okay, I can put another bucket here, right? So that it can feed both these hamsters, correct? Okay, and then I have to put another bucket which will go here, right? And it will feed this hamster, correct? This hamster. So how many total buckets we actually used? We used 3 buckets here, as you can see, right? There are 3 buckets. So this bucket is going to feed left side hamster and right side hamster, correct? Okay. Now this bucket can feed left side hamster and right side hamster, right? Okay. And this bucket can feed this hamster. So total 3 buckets will be required here, right? 3 buckets. So as you can see, this is one bucket I put here, this is another bucket I put, and another bucket I put. So total 3 buckets I will actually need to put to feed all these hamsters. So the answer for this one is 3. So but how will we decide where to keep the bucket, right? Where to keep the bucket, how will we decide that? So because we have a choice of left side, for example this hamster, right? So we have a choice of either we can put a bucket on left side or right side because both spots are empty. So whenever we have a choice of putting a bucket on left or right side, right, then you will always choose the right side. I'll repeat this sentence. Whenever we have a choice of putting a bucket on left side or putting a bucket on right side, you will always choose right here. Okay, so you will always choose right, so you will put bucket here. Why we are choosing right? Because there is a possibility that a hamster will be ahead here, right? Correct, you got it right. There will be possibility that on this spot there will be hamster, right, that can be fed with this bucket on its left side, right? So this is a greedy approach, right? This is a greedy approach. So we want to minimize number of buckets, so this is the way we can minimize number of bucket, right? Now for this hamster for example, I have a choice, right? I have a choice. I can put a bucket here or I can put a bucket here. Whenever I have a choice, I will go always with a right. So I'll always go with a right bucket here. So I'll put a bucket here, not here, right? Not here. Why I am not putting the bucket here? Because if I put a bucket here for this hamster, there is a possibility that another hamster will be here that can also be fed with this bucket, right? So that I can minimize the number of buckets. You got it right? So this is a greedy approach basically. I have a choice here. I can put left side or right side. I'll always go with right side. So I'll put a bucket here so that I can reduce the number of buckets. So in 3 buckets I can actually feed all these 5 hamsters, right? So as you can see, these are the buckets location. So this is the basic logic and greedy logic basically that we'll be using so that we can minimize the number of food buckets that we are going to be placing at empty spaces, right? So that we can feed all the hamsters, correct? If you at all see hamsters like which are H, so 3 hamsters consecutive, there is no way you can feed all these hamsters because this hamsters is surrounded by 2 hamsters, so there is no way you can put bucket on its left or right side. In this case you will return -1, right? So this is, it is impossible to feed all the hamsters. This is the case. Okay, so this is the basic logic to solve this problem. So I hope you understood this greedy logic and greedy approach. So same thing now we are going to be implementing in our Java code. So this is our Java code which we are implementing minimum buckets. A string h which is hamster string is given to us. We are going to be returning int, right, which is minimum number of buckets. First thing we will do is we'll convert this hamster string into character arrays. We'll call it as a hamsters, right? So it's a character array. So we just converted it into characters. Okay, now we got all the characters array. So we are going to loop in this for loop from index 0 and we'll be looping until end of that array. Whenever we see a h which is hamster, right, whenever hamster present there, what we will do, we will check the left part. If I minus 1, if it is greater than equal to 0, right? If I minus 1 is greater than equal to 0 and I minus 1 is actually a or it is a bucket there, right? If it is a bucket already there, if there is a bucket, you will simply continue, because already you can feed this hamster with this bucket, right? So you will simply continue basically if there is already a bucket there. Okay, so after that we will check if I plus 1 is less than hamsters dot length and I plus 1 is equal to dot. So you have a right side available on that hamster, and that available is actually an empty spot on the right side. If it is an empty spot on the right side, basically, correct? So for example, for this hamster, right side is available, yes, and it is an empty spot, yes, it is an empty spot. So you are going to put a bucket there basically, right? So hamsters I plus 1 is equal to B. So you will put a bucket here basically, right? So you will put a bucket. That's what it is saying. Okay. If else, if I minus 1 is greater than equal to 0 and I minus 1 is equal to dot, right? I minus 1 is equal to dot. For example, here, right? When you go here, right? I minus 1 is equal to dot, yes, right? I minus 1 is equal to dot, then you will place a bucket at I minus 1 location, but you will only do it if this condition is false. Okay, if this condition is false, you will only do it, right? So in this case, you will not do it basically. This condition is not false, right? So first you will always check the right side empty or not. This is very important thing. I'll repeat it again for you. You first always check if your right side is empty or not. If right side is not empty, then you will check your left side. Okay. Then you check your left side. If left side is empty, then you will put a bucket at left side. So you are greedily choosing right side first, so that you want to minimize the number of buckets. So you are always choosing the right side first. If right side is not available, you will go to and check the left side. Okay, so this is what is very important thing here. Okay, after that, if both of these conditions are false, you will come to else. It means that you have three consecutive hamsters, right? H, for example, H, this is your three consecutive hamsters, right? So in this case, the hamster which is in the middle will never get food, because he is surrounded by hamsters on its left and right side, correct? So you will have to return -1, right? It is impossible to feed all of them, because a hamster is surrounded by hamsters on its left and right, right? So you will return -1. So you will keep looping in this for loop, and you will greedily keep choosing the right side whenever possible. When right side is not possible, you will check the left side, right? Correct? And if already bucket is available on the left side, you don't have to worry, because that hamster can always get food from its left side, right? So this is what we will check here, correct? At the end, you have to just now we actually are updating our string. So this is updating our array. So after you update the array, this is how your array will look like, right? This is your updated array, correct? Now you have to just go through this array and you have to check how many bees are here basically, right? So that you can count out how many buckets you place there basically, right? So that's what we are doing. So we are taking one counter is 0. We are going through the array one more time from left to right, and we are checking all the bees in that array. For all the bees are actually buckets that we place, so we are going to count them, and at the end we are going to return the count. So we will run this code now, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is so we'll check with this all these test cases. For the first one, we should be getting 2. We are getting 2 correct answer. For the second one, we should be getting 1, and we are getting 1 correct answer. For the third one, we should be getting -1. For the third one, we are getting -1 correct answer, and this one is the fourth one that I created, so we should be getting 3 here, right? So we'll check it out now. So this is the one that I created, same test case that I just shown you. So 3 is the correct answer here. So we are getting correct answer. We'll submit this code now to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 78.7% faster on the performance side and 60.53% faster on the memory usage, which is a very good solution to solve this coding problem. So this is how you can solve and implement this code for the important problem on Leetcode 2086, minimum number of food buckets to feed the hamsters. So I hope you like this Java solution, and this greedy approach is clearly understood by you with these examples and Java code. So I am going to add this Java solution code for you in my GitHub repository and give you the link of this code so you can check it out. There are lots of other important algorithms and Java solutions already implemented and available there for you. So don't forget to check out the other Java codes from GitHub repository. They are important ones from interview perspective, and it will help you learn lots of new techniques of problem solving. So the name of the very important playlist is Leetcode and Leetcode Solutions, that has more than 200 solved problems. If you like the solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you haven't already checked the very important playlist, then there is a very important playlist we have created to help you in your interviews. It is called as Leetcode and Leetcode Solutions. The problems are compiled there, are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft many times in their past interviews. They are very important problems. Make sure you go through all of them, understand them thoroughly. If you go through those problems and videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So do check out all those solved problems. They will definitely give you a good preparation for your interview rounds. The name of the very important playlist is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems for your interview preparation, we have created 3 other playlists for you here. The names of those playlists are Code Forces, Code Chef, At Coder. Code Forces, Code Chef, At Coder. All in all, more than 800 different varieties of problems are here to help your interview preparation and learning process. If you like this Java solution, and if you like this greedy approach, how we have solved this important coding problem, minimum number of food buckets to feed the hamsters, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So do subscribe to this channel. Share this video with your friends and colleagues so they will also watch and learn from these videos, more problem solving and Java implementations. Click on the bell notification icon button right away so you won't miss any important postings from this channel. On this channel you will find lots of solved coding problems which are very important varieties from interview perspective. Those includes graphs, matrices, binary trees, breadth first search, depth first search, Cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of important data structure questions available for you here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All are important problems. Make sure you go through all of them, understand them thoroughly. If you go through all those problems, it will help you learn lots of new techniques and problem solving approaches. If you are a fresher, junior level developer planning to take Java interviews, there are lots of Java related videos we have created to help others on this channel. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries where you have to use different database concepts like inner join, outer join, aggregate operations, group and having clauses, different where clause conditions. Everything is explained for you in those videos. There are videos that discusses very important MySQL ranking and windowing functions as well for you, so that you can learn how to solve medium complexity MySQL programming questions. So go check out those videos. They will definitely be helpful for you in your interview rounds. If you like the videos on this channel, if they are helping your learning process, you are learning more techniques, more problem solving along with programming and data structures, then please do leave your messages, your feedback, your comments below these videos. Your feedback, your messages, your comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages, tell us how the videos are useful and helpful for you. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then mention those topics in the comments section below these videos so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems. If you haven't already checked the playlist on this channel, go to the playlist of this channel right away so that you will get to see all the interesting problems. We have it here for you. The playlists are divided based on the problem types. For example, dynamic programming, graphs, BFS, DFS, matrices, sliding window algorithm. All the important algorithms and important data structure problems are available for you on this channel and explained with examples and Java code. Code is always shared through GitHub repository and available for you. The links are given in the video's description section. So go check out the code, play with the code, create your own custom input test cases for your clear and better understandings. And thanks for watching these videos.